Hello and welcome back to more work with L'Hopital's rule, material from section 4.5 of our calculus text. In the previous video, we looked at the 0 over 0 or infinity over infinity indeterminate forms. And here we're going to do a little bit with a different, at least an indeterminate form that looks a little bit different initially, but we're going to see that we're going to be able to convert it into a 0 over 0 or infinity over infinity form, so we can apply L'Hopital's rule to it. So this time, instead of a quotient, we've got a product that we're starting off with, f of x times g of x. And the idea is that one of these factors, so one factor is heading towards 0, and the other is getting really big. And the idea is in a product, if one of the factors is heading towards 0, we expect the product to be getting really close to 0 in value. Whereas if one of the factors is getting really big, we expect the product to get really big. And so again, we've got this conflicting information. It seems like one thing is telling us that the product is going towards 0, another one is saying that the product is getting really big. And so therefore, we need to do something else to try to investigate to see how we might resolve this. And the key is going to be to rewrite the product as a quotient, and we'll see that the quotient is one to which we can apply L'Hopital's rule. So the key is to write, say, f of x as 1 over f of x. Possibly we might write g as 1 over g of x, in which case it's going to depend on the way the function looks is whether we're going to flip the first factor or the second factor. So hopefully we'll see that in our two examples, give a little bit of insight into what to do. So if we do this, then f of x times g of x is the same thing as 1 over f of x times g of x, but I can rewrite that simply as g of x over 1 over f of x. And let's check something out here. So suppose that the limit as x goes to infinity of f of x were 0, or let's say infinity, and the limit as x goes to a, limit as x goes to a of f of x equals infinity, and the limit as x goes to a of g of x equals 0, then what's the limit as x goes to a of 1 over f of x? Well, we would say that's 1 over a large number, since f of x is going toward infinity, and so we would say this is heading towards 0. So g of x over 1 over f of x in this case would be a 0 over 0 form. The idea if f of x is getting really big, then its reciprocal is getting really, really tiny, close to 0. Let's look at a couple of examples. Limit as x goes to infinity of x squared times e to the minus x. The limit as x goes to infinity of x squared is plus infinity. The limit as x goes to infinity of e to the minus x. Well, if we raise e to a bigger and bigger negative power, that's getting closer and closer to 0. So this is an infinity times 0 form. And the way we're going to handle this is we're going to think about e to the minus x as 1 over e to the x. So the limit as x goes to infinity of x squared e to the minus x is the same thing as limit as x goes to infinity of x squared over e to the x. And so now this is an infinity over infinity form. Both x squared and e to the x are getting really large as x gets really large. And so I can apply L'Hopital's rule to this. And so this is the limit as x goes to infinity of 2x over e to the x. This is still in an infinity over infinity form. And so I apply L'Hopital's rule a second time. I get 2 over e to the x. And now this is headed toward 2 over a large number. And so we would say that this limit is 0. So in this case, the 0 won out. Another example is the limit as x goes to infinity of x times the natural log of 1 minus 2 over x. And so I've got an option here. I can rewrite either x, do I want to write x as 1 over x, or do I want to write natural log of 1 minus 2 over x as 1 over natural log of 1 minus 2 over x. Well, I think this one is going to be the easier way to go, assuming that we have an infinity times 0 form. So let's check that out. The limit as x goes to infinity of x is indeed infinity. The limit as x goes to infinity of natural log of 1 minus 2 over x. Well, that's going to be the limit, or the natural logarithm of the limit as x goes to infinity of 1 minus 2 over x. Well, as x gets really big, this part's going off to 0, and so this is the natural logarithm of 1, which is 0. So this is an infinity times 0 form. So indeed, I do want to take and invert one of them, and we're going to flip x over. So I'm going to write the limit as x goes to infinity of x times the natural log of 1 minus 2 over x as the limit as x goes to infinity of the natural logarithm of 1 minus 2 over x over 1 over x. So this is a 0 over 0 form. 1 over x is getting really small as x gets big. 2 over x is getting really small, which leaves me with natural log of 1 or 0 inside. So this is a 0 over 0 form. So I can apply L'Hopital's rule. I need to use the chain rule to take the derivative of that numerator. So the derivative of the natural logarithm of 1 minus 2 over x is going to be 1 over what's inside, 1 over 1 minus 2 over x, times the derivative of what's inside, and that's going to be 2 over x squared. So the derivative of 1 is 0, the derivative of minus 2 over x is negative 2 over x squared, or 2 over x squared. And the derivative of 1 over x is minus 1 over x squared. So now let's see what we've got here. So I've got 2 over x squared over 1 minus 2 over x, and I can rewrite this part as just simply minus x squared. 1 over negative 1 over x squared. So I'll write this out. Sorry. 1 over negative 1 over x squared is the same thing as minus x squared. So let me know if you have any questions about that. But now I can see, let me go ahead and continue to rewrite this a little bit. So I get minus 2x squared over x squared all over 1 minus 2 over x, and now the x squareds cancel. And I've got limit as x goes to infinity of minus 2 over 1 minus 2 over x. And now as x gets really big, that's going to 0. I'm left with negative 2 over 1, and my limit this time turns out to be negative 2.